My friends and I built this graphics demo without using any high-level libraries, just pure WebGL. To draw the scene, we created a set of large mathematical formulas that calculate the exact color of each pixel in each frame using only a pixel's coordinates and timestamp as inputs. For now, let's just focus on the formula for the sky, though the following principles also apply to the clouds. To get the realistic colors of the sky and sunlight, we simulate the actual atmosphere. You just can't cheat something as pretty as the sunset. Every color you see is calculated by emulating light rays that originate at the sun. These rays bounce around the atmosphere hundreds of times, then eventually make their way to your eye, either directly from the sky or reflecting off of the ground. Each time a light ray bounces in the atmosphere, we use equations to model how the photon's wavelength changes by interacting with the oxygen, water, and nitrogen molecules in the sky. What makes this especially hard is that countless light rays reflect from all over the atmosphere to each spot on Earth, so every pixel would require thousands of calculations. Since we render over 200 million pixels per second, that might add up to trillions of operations per second. Now for the hardest part. Even though we run these calculations on your GPU, it can't handle this many. We need to find some clever approximations that don't compromise the visual effect. The primary approximation for the atmosphere uses some pretty dense calculus. This math solves as much of the total atmospheric interaction as possible ahead of time. Then, by storing the results in a table, we can offload significant parts of this formula to a single lookup, reducing the number of calculations from thousands per pixel to mere tens. This comes at the cost of only slight banding at certain extremes like sundown, where the table loses precision. Pretty cool. Visit the link in the description to try out the demo for yourself. Also, I didn't invent the ingenious math behind this, so a link to the original paper is down there as well.